Step 2, 2008 question number 1. It's also question 6 from the Miscellaneous Pure Step 2 support module. It's a question about sequence here. We've got x1, y1, x2, y2, and so on. And there's a rule for generating them. If you know the previous one, you can get the next one via all of this business. In part 1, we're told a is 1 and b is -1. So, okay, all of this clears up to be this, I guess, with a is 1 and b is -1. -1 plus 2 is just 1, I guess. And we want to know when the sequence is constant. For a constant sequence, x1, y1 is going to be equal to x2, y2, which is going to be equal to x3, y3, and so on. So, okay, well, x2, y2 is just what happens when you put in the first terms. But we need this to be x1, y1. So therefore, we need x1 to be this stuff, and we need y1 to be this stuff. So we can put that down. And we'll just solve these two simultaneous equations for x1 and y1. Now, at this point, I'm going to let x1 equal x and y1 equal y, just because it's annoying to type all those subscripts into PowerPoint. So I'm just going to pretend we're doing x and y's, but at the end, I'll hopefully write it correctly. So anyway, we ended up with these two things here. I'm going to rearrange this one for x, because that's not hard to do. And then I'm just going to shove that result in here. There's probably much more intelligent ways of doing these bits, but I know this will work, so I'm just going to do it this way. When we expand that out, of course, this is y -1 times y -1 on the top there, so it makes this. And we expand the bottom as well. We can times everything, I guess, by 2y if we want to. And then I think I'm going to move some stuff over and then times by 2y again everywhere. And do that, and then rearrange some terms. And what do we get? Well, we get a quadratic that's hidden. But if we just in our mind's eye replace this maybe with 4, x probably isn't a good shout because x is already in the question, but 4t squared minus 3t minus 1, does that factorize? After a little bit of trying, you get that it does indeed factorize, and you can just replace the t's with y squareds again. So I think this definitely works. We get minus 4y squared plus y squared, so that all works. That's good. And so yeah, so either this is 0 or this is 0. This has no solutions, obviously, because you end up with y squared equals -1/4, so no real solutions. But this one has y equals plus or minus 1. And if y is plus 1, maybe from here, if y is plus 1, 1 minus 1 is 0, so x is 0 immediately. And if y is -1, -1 minus 1 is -2, over -2 is a plus 1. So these are our two solutions to this. For, I should have probably written again, x1 equals this, y1 equals this, or x1 equals that, y1 equals that. But I just made that to make it a bit easier for myself. Anyway, now given that x1, y1 is this, now that's actually, interestingly, one of the cases we found. So that's cool. But this time we're not given a and b was what we had before. So we can't really use that to any massive extent straight away, because we've now got that a and b is just got to be in here. And we're looking for sequence period 2. Now, period 2 means that we start on a thing, then we go to not that thing, and then we go back to the original thing, and then not that thing, but it has to be the same as the second one was, and then back to the original thing again. So it's kind of a yes, no, yes, no, yes, no situation. So, okay, well, that means, again, just putting in x2, y2 equals these things in here. Well, we can put in x1, y1, because we're told those are these this time. So it's kind of backwards what we were doing last time, but we're told that. Now, this very nicely becomes 1 minus 1 plus a is just going to be a, right? And this also becomes a -2 plus 2, so it's just b. So that's very nice of it. So now we know the second term. And now the third term, we can just put the second term into here to find the third term. So put an a squared and a b squared in there, and a 2ab in there with a b there, and we end up getting this thing. So x3 is this, and y3 is that. Simplified up. But remember, x3 and y3 have to be x1 and y1, because this sequence starts at x1, y1, and that's the same as x3, y3, because it goes yes, no, yes, no. So x2, y2 is AB. We already actually found that one. So it goes, so this sequence needs to go -1, 1 to AB to -1, 1 to AB to -1, 1 is going to be x5, y5, right? So in other words, x3 has to be -1. So we can say -1 equals this, and y3 is 1. So 1 equals that. And we can try and solve this. So here it is. We can try and solve that for a and b. And again, probably some intelligent things you can do here. I did it in literally the most mechanical way possible. I just rearranged for a again. I squared it because I sort of wanted this. I actually squared 2a to get 4a squared, but I can times all this by 4, so that's going to be okay. We end up with this, of course. This squares, negative squares the same as positives do, so I can just do that. And we end up with this. If I times this by 4, sorry, then I can just throw this result in here. And 4a is just like double this, so I'll just double everything in there to put it there. And yeah, this looks pretty good. This is an equation in b. I guess I can times by b squared everywhere, or I just put this over there and then times this by b to combine them, and then times by b squared everywhere. And then if you rearrange, you could think about solving this equation, but actually, as is often the case in STEP, this has already been done already in this video. It had y's in it before, but this is the same quadratic that we saw before. You can go back in the video if you need to make sure, but it is definitely the same quadratic. The solutions were plus and minus 1, and those were the only solutions. So therefore, either b is 1 or b is minus 1, and we can just verify what the a is in that case. So we can do some solving. In this case, if b is 1, we get a as minus 1. And in this case, if b is minus 1, we get a as 0. Now, we do have to be a bit careful here, because if ab was minus 1, 1, that means the second term is minus 1, 1. But the first term was minus 1, 1. So if this is the case, then this sequence just goes minus 1, 1, minus 1, 1, minus 1, 1, minus 1. I can sit here all day, but it's a constant sequence. It's not period 2. It's sort of on a technicality period 2, because the first term is the same as the third. But period 2, you're not allowed to have the second term the same, really. So we don't have this. Now, this term is okay, and I don't even need to check it, because I know AB is the second term. So this sequence goes minus 1, 1, 0, minus 1, minus 1, 1, 0, minus 1, and so on. So that's good, and we'll have, that's the end of the work. We'll have the entire question done, and thanks for watching.